Do it. Oh,
Oh,
I got you. I got you. Yeah, it's kind of how they always. Oh, right. I think it was.
Oh, yeah, yeah.
It was a little. Yes.
Yeah, I'll make the video.
Yeah. I didn't notice that. Friday was a turn, so when I sit down with something. Until 10 minutes or something. So, this is and then
Okay, folks, I know I just put a lot of stuff on the board. I'm gonna pass back your exams. There was, even though basically when you get the exam back, you can add 11 points to whatever your point total out of the 150 was. Because I haven't added it officially on the exam itself. I've done it on a piece of paper that I'm going to go in and enter the grades as soon as I get back to probably tomorrow, because I've got labs all day today. So, if you did not perform well, it's okay, because you get to drop your lowest exam. But it means that the other 3 exams this semester have to be better. Some of you did really well, and others struggled significantly. And so as soon as I pass back the exams, I'm not going to go over the exam. I'll make sure we save some time and you can look at the answer key to see what you missed. But I do want to have a discussion because I need to know what I need to do differently. So, Katie Atkinson, Macy Broadway, Katie Duran, Mackenzie Fresneda, Macy Handwork, Samantha Holt, Second, Addie Keith, Zach Lunk, Jackson McCormick, Grace Nelson, Andrea Pelos, Corey Parker, Thor Perez, Lisa Sahib. Janaya Smith. AJ Smithwick. Elizabeth Ward. Now, I know these tests are not easy because for the most part, there's no partial credit that can be given. The answers are either right or they are wrong. Overall, I thought there were only 2 questions that were potentially tricky. And those 2 questions were (15) E and G. Because on 15 E and G, there were multiple answers. Otherwise, I thought it was fairly straightforward. As far as the chemistry. But apparently I was incorrect. So now what I want to do is, before we get into today's information on amines, I want to talk about what you need that I'm not providing. To see if I can correct what is going on. So I have my little sheet of paper I'm going to write information on. And as I indicated the very first day, I'm open to feedback. That's why I'm doing this, is I want to take a moment and figure out what I need to do for you to help improve the next exam, because the next exam will cover most of the aldehydes and ketones. It'll cover most of chapter 15, 16, 17. I know it's going to cover those 3 chapters at least. Probably get into hopefully chapter 18 at that point too. So now I need feedback. What can be done?
For me, I think it was a lot of the reactions. I don't know, because you did give examples, but I don't know that I understood it enough going into the exam. I was looking at it, but then I just think maybe some more examples would help.
Speaking of reactions, one question I have is, at the end of each chapter, there was a section that went over the reactions. And basically it was after the flow chart on the organic chemistry family. So it was a summary of reactions. How many people took time to really understand those reactions? Because that summary of reactions can condense a lot of what was discussed in class down to a smaller section. So taking those summary of reactions and rewriting those reactions and trying to understand what those reactions are saying may help some, because it specifies whether it needs a catalyst, it specifies whether it's oxidation, reduction, what it is. And so those may help some with that. I'm not saying, I'll try to do more examples as well, but that is one thing that may help.
No, you said that's at the end of each chapter.
At the end of each chapter, there's a summary of the reactions for that chapter. Other comments?
I know for me, it was just the two exams kind of put together, and so just a lot of information on one exam, so I feel like the second exam is gonna be a lot less like stressful studying for it. Yeah, it was just like information.
Well, and it's the first exam, which is always a challenge. Other comments? Because I do think it's important to hear your feedback and what you need. What I can do differently. For some, there's not a lot I can do differently, but for others, I know that there's a need. Let me ask a question. Was there anything on the exam that was completely that you felt was completely out of left field, or was the exam pretty much what we went over? It just was a lot of material. You know, I can't do anything if it, as long as I've gone over the material, then I feel like it's valid. But I want, was there something that was on the exam that you did not expect at all?
I just feel like some of the reactions, like, because I went through the book and like did a lot of the book questions and really thought, like, oh man, I really got these reactions down. Like, I was getting them right and everything. And then now I'm looking at it and it's like, I don't know, the reactions I guess were kind of different on the exam than they were in the book. And I used the information, you know, that I learned from doing them in the book, but I guess it somehow didn't translate over just for certain ones, like some of the like alcohol reactions or the halogenations. It's like I was studying one thing, thought I had it, and then when it came down to the test, some of the questions just kind of didn't know.
Do you think additional reactions would be the way to go, or
You said you think,
do you think that additional reactions in class is the way to go?
maybe,
Or
and I wondered, like, I know active at the bottom, it has like a practice thing. I don't know what that, like, whenever I click it, it says there's nothing there, but
yeah, I
don't know if
haven't
they
put
have-
in any practice problems because I have so many homework problems that
gotcha.
I haven't wanted to overwhelm you with more.
Oh,
So that would be what that would, I have to go in and put in practice problems, but I'm struggling at times to find problems that match because they use a different textbook for the active than they do for that than our textbook.
gotcha.
And so I'm trying real hard sometimes, and as you've pointed out, some of these questions are like, I don't get it.
Right.
But it's because it's from a different textbook and they stylize their things a little differently. So I'm trying to be careful about that, but
Oh,
sometimes I still screw up.
so the ones on the test are more similar to the ones.
The ones on the test, I try to be more, make them more similar to what's in the textbook and what I do in class
Oh,
than what is on active, because again, the active comes from a different textbook, so I have to be cautious.
I think for me, kind of going off what Zach said, is like I study like things that look a certain way, and then like in my head they can only look that way, and then when I see like stuff on a test and it doesn't look in that form, then I'm like I can't comprehend it.
So what
So
I-
maybe like in
what you
class-
got to do is look for trends and not specific examples. like every time you come across a disulfide, which most people got that one right. But you look for the trend rather than a specific example. Oxidation, I don't actually memorize a specific example. What I know is if I have a primary alcohol and I oxidize it with plenty of excess oxidizing agent, it's going to go to carboxylic acid. If I have a primary alcohol, so I don't memorize the reaction, I memorize that concept. And so that may be something I need to stress, is the concept of the reaction rather than a specific reaction.
For me, I don't think it was anything that you did per se. I think it would have was more so my preparation. Because on Monday, I spent like 12 hours studying for this exam because I was so nervous. Like not consecutively, but like broken up. And I don't know, maybe not doing it because kind of froze on the exam. So,
Okay. Well, if you come up with more things that you want to, and you don't want to say it in front of people, feel free to email me. I'm not taking, I do in a sense take things personally because I want my students to be successful. But I don't take it personally if you want to yell at me because I need to find out what's going on. So, anyhow, I want to know what I need to do to help you. And it may be that you ask around. Because you did have some classmates that did well, and they may have a study technique that you needed to know about. And I can't answer what you need because I don't know what you need unless you're talking to me, so. Any questions? I'm sorry if I've rambled. It is more out of a concern for you rather than, and like I said, you can still drop an exam. Other things that I've put up here is, first of all, again, that grade is going, when it goes into Blackboard, is going to be 11 points higher than what's on the test. Because I did curve it by 11 points. The second thing I wanted to make note of, and I was planning to do this no matter what these test scores, but obviously this can come in handy with these test scores, is there are bonus opportunities that you can do. It is strictly up to you whether you do them or not. You know, I'm not going to force you to do things, but these are bonus opportunities that are available to you. And if you can't make something, talk to me and I might can come up with something else. Because I know it's like the last one. I'm big on donating food to the Bear Food Pantry, but I know not everybody can afford to do that one. So if it's a, you know, if there's an issue, if you'll talk to me, then I might can come up with another opportunity. I like this one for this class because so many of you are nutrition majors. And so you know how important it is to have food security. And so I like this one for this class in particular because of food security for our fellow students and fellow staff, faculty. But if you can't afford it, you can't afford it. You're one of the ones that may need the Bear Food Pantry. And so I'll come up with something else to get you those 20 points. But these are just bonus opportunities. Any questions? Yes.
Was the grade breakdown, was that before or after the curve?
That was after. That was after. So. Any other questions? Yes.
So what will we do on Zoom? Do you want?
So what this is there are two lectures. The first one is about nutrition, actually. The second one is about electric cars. And basically you would register, you would be on Zoom. And as long as you're on listening to the lecture, it's 5 points automatically. If you take notes and then bring me those notes, it'll be 5 additional points. So you can earn up to 10 points for going to the lecture.
So further question.
Yes.
Can we only do one lecture? Can
Yes.
both?
You can do
all three?
You can do all 3 items. You can do one of the items. You can do none of the items. This is opportunities, not requirements. And the bonus opportunities, those 30 points, because you can earn up to 30 points. That's a 3% curve, roughly. It's going to be added to the end. It's not added to a test. It's added to your end grade. So if this test is the one you drop, you'll still have your 30 bonus points. If it's the next test you drop, you would still have your 30 bonus points because it's added to the end of the semester, not to a specific exam. Other questions? I don't like adding them to specific exams because if I add bonus to specific exams and you wind up dropping that exam, you lose that bonus. So that's not fair. So I just put it on the end. Any other questions? I know I've used 20 minutes of class, but I think those 20 minutes were worthwhile 20 minutes. Okay, so we are going to get into amines today. An amine means that you have a nitrogen group. I need to write bigger. You can have ammonia, which you should have learned about in your previous chemistry course. Ammonia is, in a sense, the simplest of all amines because it's a nitrogen group that has 3 hydrogens surrounding it. You can have what is called a primary amine. And folks, this is same type of concept as we've done before. In that, what a primary amine is something that has 1 carbon group attached to it. Just like a primary alcohol is something that has 1 carbon group attached to it. A primary amine is something that has 1 carbon group attached. You have a secondary amine. And it means that it's going to have 2 carbon groups attached. You can have a tertiary amine. And it is going to have 3 carbon groups attached. Now, something that we haven't really talked about, though we've seen, is you can have cyclic amines, which just means that the nitrogen group is somewhere in the cycle. It could be a pentylamine. The nitrogen is in the cycle and it has an R group attached. Now, I'm not going to make you memorize a lot of cyclic ones, but one of the cyclic ones that you will need to know is the 5-carbon structure, or well, 4-carbon structure with a nitrogen at the 5th point, and this is called pyrrolidine. Now, we can have a quaternary, come on. Amine. And it becomes an ammonium ion at that point. And in this particular case, the nitrogen is positively charged. It's going to have 4 groups attached to it. Folks, you may have seen something like this in college in your general chemistry for health sciences course. In that particular case, what you saw was this, which you called ammonium. So what do you need to know out of this? First, you need to understand primary amines. They have 1 carbon group attached to the nitrogen. You need to understand what a secondary amine is. It has 2 carbon groups attached to the nitrogen. You need to understand what a tertiary amine is. It has 3 carbon groups attached to the nitrogen. You need to understand a quaternary ammonium ion, which has 4 groups attached to the nitrogen. I say 4 groups because most likely 3 of them, most likely 3 of them will be carbon. The other one may be a hydrogen or another carbon. It doesn't matter. It has to have 4 groups attached to the nitrogen to be a quaternary ammonium ion.
Question.
Yes.
If we had like alcohol attached to the, will we ever see that alcohol attached?
To an amine?
Yeah.
That is always a possibility that you'll have an alcohol attached to amine. And I want to say that, well, we do have a way to name an amine that is attached to something else, which I was actually fixing to get into.
But if it was like the quaternary ammonium ion, would that still be a coordinator ammonium ion, or would it be something else since there's an alcohol?
Okay, so if there is an OH group, it's attached, it depends upon how it's attached, because OH is typically a negative. So it would be a salt that forms between the quaternary ammonium ion and the hydroxide ion. Now, if the amine is the substituent, it is called an amino group. When have you heard the term amino? Amino acid. An amino acid is, the acid is the more important functional group. So the amino is the amine as a substituent.
So which substituent is more important?
Part of it is, as we've gone through this text, the biggest substituent that usually gets the parent name is a double bond. And everything else to that becomes more of a substituent. So an amino group, a hydroxy group, they're all substituents if you got a double bond. Otherwise, we have been steadily increasing who is more important. So alcohols, they tend to always be listed as the substituent unless they're the only thing. And so they become hydroxy groups. Aldehydes and ketones, they are going to be listed as the parent typically because of the carbonyl group. That carbonyl group is super important. So what we've been doing is we've been steadily increasing who is more important. The amine group is probably less important than the carbonyl. So the carbonyls are going to be more important than the amine. But in general, well, compared to hydroxides, the amine is more important. Did that answer your question? Part of it is just experience, but part of it is that we've steadily been increasing who is more important, especially with biological reactions. So alcohols are less important in biological reactions than the amines. So. Okay. Questions about primary, secondary, tertiary, and quaternary? And identifying them, because there's likely to be a question similar to what was on one of the on the test where you had to identify primary, secondary, quaternary. But it'll be about the amines. Okay, so let's get into naming. Folks, you will not be able to do the naming of amines unless you can determine whether they're primary, secondary, tertiary, or quaternary. So if we have a primary amine, you identify the alkyl group. Attached to the nitrogen. And add the suffix amine. So for example, this is a primary amine. First of all, how did I know it's a primary amine? Only one carbon group attached. So I identify the alkyl group. That is the methyl group. And then I follow it with the word amine. This also is a primary amine. How do I know it's a primary amine? There's only one carbon attached to the nitrogen. So I identify the alkyl group. In this case, it's cyclohexyl. And then I follow it with the suffix amine. Questions about primary amines? They are pretty straightforward. Okay, with secondary and tertiary amines, the first question you have to ask, are the alkyl groups the same? If you answer yes, then you're simply going to add the prefix di or tri to the alkyl amine. An example would be CH3, CH2, NH, CH2, CH3. I asked the question. First of all, what type of compound is this? Primary, secondary, or tertiary? It's secondary. Why? 2 carbons attached to the nitrogen. So I asked the question, are the alkyl groups the same? In this case, yes. They are both an ethyl group. Since they are the same, I'm going to use di or tri. So this becomes diethyl amine. Okay. Yes is easy. Relative. It's the no that's hard. The no is going to be the first time we encounter something that we haven't experienced so far. If you answer no, then you have to indicate that it is a nitrogen substituent by adding N dash before the alkyl group name The alkyl groups are still alphabetical. So step 1 is to identify the longest chain. And that becomes the parent. Step 2 is to indicate all other alkyl groups attached to the nitrogen as N dash followed by the alkyl name. So let's look at an example. Let's look at a few examples. Primary, secondary, or tertiary? Secondary because 2 carbons attached to the nitrogen. Going back up here, are the alkyl groups the same? No. So we find the longest chain. And the longest chain is the propyl group. So this will be a propylamine. As the parent. Now we need to name the other substituent. The other substituent is the ethyl group. And the ethyl group is attached to the nitrogen. So we say it is attached to the nitrogen. So that becomes N-ethyl propylamine. In other words, the nitrogen has kind of sort of replaced our numbering system that we were using previously. Let's look at another example. Primary, secondary, or tertiary amine? Tertiary, why? 3 carbon groups. So we go back to the original question. Are all the alkyl groups the same? No. Since they are not the same, we identify the longest one. In this case, it's the ethyl group. And that becomes the parent. So it's ethylamine as the parent. Now we go in and identify the other substituents, which are both methyl groups. Both methyl groups are attached to the nitrogen. So we have to say both methyl groups are attached to the nitrogen. So it's NN dimethyl ethylamine. What?
Can you do one that would be a second?
Sure. Primary, secondary, or tertiary? Secondary, because there's 2 carbons attached. Are the functional groups the same? No, they're different. Are the alkyl groups the same? No, they're different. So we identify the parent. In this case, the biggest one is going to be this cyclohexyl group. So the parent is cyclohexylamine. Our other functional group is a methyl group. That is attached to the nitrogen. So we're going to say that it's attached. So it becomes N-methyl cyclohexylamine. Okay. So the next thing is I want to just briefly so as my pen works, there we go. Do something so that you can see an amino group as a substituent. The example would be this. As I mentioned previously when I was asked about the order, double bonds are always the most important. So since the double bond is the most important, come on, give me my little thingy. That means that the carbon chain has to be our parent. And we want the double bond to be the lowest number possible. So it gets the number 1. In this case, the amine group has to be the substituent. So the substituent is on, so our parent, let's get the parent out of the way first. It would be 1-butene. That's the parent. Now we have to name the substituent. And because it's an amine group, it gets the name amino. So this becomes 3-amino 1-butene. Another thing that I want to mention is the an amine attached to benzene. First of all, if you have an amine attached to benzene, this right here is known as aniline. I don't remember if that's one of the ones I asked you to memorize previously. I'm looking it up real quick, if I can find it. It was a long time ago. Yes, it was. So you do need to know aniline now. So what happens if we attach a CH3 group? Folks, it's the same as what we've been talking about. Is this a primary, secondary, or tertiary? Secondary. Are the alkyl groups the same? No. So who is the parent? The parent is this benzene ring attached to the nitrogen. So it is going to be called aniline as the parent name. Now, we have to still identify the substituent, which is methyl group. And the methyl group is attached to the nitrogen. So it becomes N-methyl aniline.
So the highlighted part that's yellow is the parent group.
That's the parent. Just like phenol, when we were dealing with alcohols, phenol was a parent by which we named other things. Aniline is a parent of the compound because it's the benzene ring with the amine group attached. Do you want to practice some? Okay. So, first of all, we're going to identify the following. As primary, secondary, or tertiary amines.
You said this is more like what example? Are these from the book or?
These are from the book. Okay, so the very first one, primary, secondary, or tertiary? Primary, because it only had one carbon attached. The second one, primary, secondary, or tertiary? Secondary, because it has two attached. Third one, primary, secondary, or tertiary? Fourth one, primary, secondary, or tertiary? And fifth one, primary, secondary, or tertiary? Okay. Let's name them. Oh, but you don't have to name D. I would not put D on a test for you to name. But the other four you should be able to name. Purple. I would have made it isopropyl.
Oh, okay. Okay, this still would be up.
Yeah.
I was like, is isopropyl more important than propyl or?
No, purple is.
Oh, so just be alphabetical because it's the same number.
It is, but it's actually straight chains. If you notice, we typically make them the
True,
parent.
because you can go
Right.
1, 2, 3 instead of 1.
Right.
Oh, okay.
Straight chains are typically the parents. I mean, unless it's like a benzene ring or something, or a cyclic ring.
You said don't name D.
Don't name D. We haven't done anything that complicated where we had two cyclic rings. Okay, so the first one, because it's a primary, you simply name the chain followed by a mean, or name the alkyl group followed by a mean. So what would it, so it was hexylamine because it was a 6-carbon chain. The next one we said was secondary. And if you were to draw it out, you would have had CH3, CH2, CH2, NH, and then attached to that would have been a CH, CH3, CH3. As I was mentioning while you were doing this, the straight chain is usually the parent chain. If you go back to the very first chapter we were in, chapter 12, the parent chains were always the straight chains. So that's why the propylum, the parent was simply the propylamine. And the substituent was the isopropyl group. And since that isopropyl group was attached to the nitrogen, hence the N in front of it. So N isopropyl propylamine. The next one, actually, I could have done a straight chain, but this entire structure is the T-butyl group. So that's why I just called it T-butylamine. And then the last one, the parent was the aniline on which you had 2 methyl groups attached. Questions? Yes.
So on C, on a test, if we wrote in dimethylamine, would it still work?
N dimethyl ethylamine, yes, it would still work.
But, or you could write just T.
T-butylamine.
So,
It's most likely going to be found as T-butylamine, but I would have accepted N dimethyl ethylamine.
definitely more of a mouthful.
Okay, questions? Let's talk about properties of amines. First of all, if you have a primary amine, or if you have a secondary amine, you have the presence of an NH. So what does that mean with respect to intermolecular forces? If you have an NH group, what does that mean with respect to intermolecular forces? It can hydrogen bond. So if I compare an alkane with an amine, with a primary or secondary amine, who is going to have the higher boiling and melting points? Who would you expect? The amines. So in this particular case, it would be the alkane is going to have a lower one than the amines. Because an alkane only has London dispersion, compared to the amine, which has hydrogen bonding. And again, we're talking primary and secondary here. Very important distinction. Okay, let's add in the tertiary. So where did the tertiary amines fit? If you think about a tertiary amine, whoops. A tertiary amine is going to have what kind of structure? It's going to be trigonal, pyramidal. In other words, you're going to have this nice pyramid. Let me draw it the way I'm used to so I can get it straight. You're going to have this nice pyramidal structure with this lone pair. And if you look at the structure from a electronegativity standpoint, it is going to be more electronegative in the direction of the nitrogen. So it's going to have a dipole moment towards the nitrogen. Because it has that polarity, this is going to have dipole-dipole forces. Not right today. But it does not have hydrogen bonding because there's no hydrogen attached to the nitrogen. So I go back to the question, where do the tertiary amines fit? Between our alkane, in that realm of alkanes and amines.
You lower boiling and melting the amines, but more than alkane.
Correct. So you would have an alkane still is going to be the lowest because it only has London dispersion. Followed by the tertiary, which can has dipole-dipole. Followed by primary and secondary, which can hydrogen bond. Now, so that is the boiling, melting and boiling point. I will add that if we were to look at alkanes, amines, and alcohols, then it would go alkane, the tertiary amine, the primary secondary amine, followed by the alcohol being the highest. The reason is these last two, they can all hydrogen bond, but the OH bond makes for a stronger hydrogen bond. Than the NH. And that is simply due to the difference in electronegativity. When you look at the OH's electronegativity, it is there's a greater difference between the oxygen and the hydrogen than there is between the nitrogen and hydrogen as far as differences in electronegativities. Now, if we talk about solubility in water, all amines primary, secondary, and tertiary can hydrogen bond with water. The tertiary can hydrogen bond with water due to the lone pair on the nitrogen. Basically, because all amines can hydrogen bond with water, including the tertiary, it, all amines up to about 6 carbons will be soluble in water. If you go past that, the carbon chain takes over. And so it's much more difficult for it to, the hydrogen bonding is not as important as the London dispersion forces from the carbon chain. Amines tend to be volatile. And have unpleasant odors. One example is rotten flesh, such as that of a cadaver. Rotten meats, those are amines. When you smell rotten meat, what you're smelling is the formation of an amine. One thing we'll talk about is amines tend to be weak, Bronsted-Lowry, or Lewis bases. Many amines are physiologically active and many are toxic. We are going to talk about the Lewis acid-base nature of amines and the ammonium salts that they form. tomorrow, and that will finish up chapter 16, and we will start talking about carboxylic acid. So as far as what to read for tomorrow, if you are reading, 16.5, 16.6. And then we start into chapter 17. So 17.1. And that's all we're gonna get to, because 17.1 is huge. We may not even get to all of 17.1. So. But I promised you a little bit of time that you can look at the answer key if you so desire. And so I want to give you that time. Yes.
This lab that was supposed.
We still have not covered the material in that lab. So we can't do it until we cover carboxylic acid. So I will let you know when it's due. No, it's not. That's something I still need to do. I apologize, folks. I have not gotten things updated because for the last 3 weeks, I've been dealing with migraines at least 4 days out of 7. So I have not been mentally capable of looking at anything because all I can do is stay in a dark room. So.